In this video, we're going to talk about several different ways we can draw our organic compounds. So the first method here is called the expanded structural formula. So this is the most detailed. So everything is expanded out, everything's drawn out. You're going to see all of the carbon atoms, you're going to see all of the hydrogen atoms, and you're going to see all of the bonds that attach them together. So this first one is just a one carbon with 4 hydrogens. Second, here we have carbon-carbon bonds, each carbon attached to 3 hydrogens, right? Everything is drawn out. So that's what the expanded structural formula is. We can also do what's called a condensed structural formula. So condensed, we're shortening things down a little bit, not quite as much detail. So here we're going to write all of the atoms. So we have C's and H's, but we don't show the bonds to hydrogen. So here's a carbon with 4 hydrogens attached. If I look at the next example, I have carbon with 3 hydrogens attached. That carbon is then bonded to the next carbon, which also has 3 hydrogens attached. This third example, my first carbon has 3 hydrogens attached. It's attached to the next carbon that has 2 hydrogens, attached to the next carbon that has 3 hydrogens. Okay, so you can kind of work your way down the chain to write the condensed structural formula. Now, the condensed structural formula may or may not actually show the carbon-carbon bonds. So it's also commonly just written as CH3CH3 or CH3CH2 CH2 CH3. So don't take the added detail of showing the carbon-carbon bond. This textbook likes to show those bonds. Okay, so I will try to stick to this, but it's not necessarily wrong unless you're explicitly told to show the bonds to leave them out. So here's an example of going from the full expanded structural formula, which is the first one, to the condensed. And then we have an even more condensed version down here on the bottom. Okay, so again, let's just work our way down the chain. First carbon has 3 hydrogens, so CH3. Second carbon has 2, CH2. And then each of these, so there's 1, 2, 3, 4, 5 more. So 1, 2, 3, 4, 5 more are all CH2s. So CH2, CH2, 2, and so on. Till I get to the one on the end that has 3. So there's your CH3. So notice how there's some repeats. So all of these CH2s are repeating in the middle. So there's 1, 2, 3, 4, 5, 6 of them. So another more condensed way of doing it is we've got our CH3s on the ends. We have the CH2s in the middle. We put that in parentheses, and on the outside of the parentheses say how many there are. So because there's 6 CH2s that repeat, we can abbreviate that even more. Now this only works if that repeat in the middle really is a repeat. Everything has to be the same so that we're just writing one thing in the parentheses and then how many of those things there are on the outside. One more type of formula, or one more way we can draw our structures, is called a skeletal structure. And in the skeletal structures, all you show are the carbons and how they're bonded to each other. So all of the hydrogens are completely eliminated. And this works because we know carbon has to have 4 bonds. So if you were given this structure and asked how many hydrogen atoms are there, you would go through and count. So there's 3 on that carbon, 2 on each of these, and 3 on this end. Or we've got 1, 2, 3, 4, 5, 6, 7, 8 carbons. So if I use that formula that I know, the 2n plus 2, that means there's 18 hydrogens. Okay, so these skeletal structures work, all right, depending on what you're doing, right? If we're trying to do chemical reactions or something, they're not overly helpful because usually we want to see that carbon-hydrogen bond. But sometimes it is a little bit easier just to look at those carbons. So skeletal structures are one more way to draw our molecules. So in this example, we're going to interconvert between our different drawing methods. So we've got an expanded structural formula given. we want to draw the condensed structural formula, and it does say to show all of the carbon-carbon bonds. So we need to need to show those. Then we also want to convert the expanded into condensed formulas where we're using parentheses in our subscript for the repeats, so all of the CH2s in the middle. And then we're going to lastly convert it to a skeletal structure. Okay, so let's do the condensed with the carbon-carbon bonds showing first. So we've got a CH3 attached to a CH2, attached to another CH2, attached to a third CH2, and then the one on the end is a CH3. So just notice I'm working my way down, so CH3, CH2, 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 CH3. If I want to then use the repeat version, I've got CH3 on the end, my CH2s that repeat in the middle in parentheses, and there's 1, 2, 3 of them, so I'll put a 3 on the outside, and then another CH3 on the other end. So that's your condensed structural formula with your parentheses. Then skeletal is where we just draw the carbons. So I've got 5 carbons, so there's the skeletal structure. Same thing here. So go ahead and pause the video and see if you can draw the 3 options. So condensed, where all you're showing the carbon-carbon bonds, condensed using the parentheses and subscript, and then skeletal. All right, here's your 3 answers. Check yourself, and then you can move on to the next problem. All right, in this case, we are going to be given a formula for number 1. So we're given C5H12, and we want to draw the expanded structural formula for that given molecule. So we know we have 5 carbons. So we're just going to stick those connected to each other. So this continuous chain statement here means your carbons really are just linked in a continuous chain, right? Just a chain of carbons. Then to fill in the hydrogens, we're going to remember each carbon needs 4 bonds. So if I put in 3 hydrogens on the first, that gives it 4 bonds. The ones in the middle are going to need 2. They already have 2. And then the one on the other end will also get 3. So now if you go in and check, that was 12 hydrogens used. Last example here says the expanded structural formula for this condensed. So we've got CH3, and then we're going to have 6 CH2s. So 1, 2, 3, 4, 5, 6. Each of these are going to have 2 hydrogens. And then on the end is another CH3. We've got one more example here. So this time we are given the formula C10H22, and we want the condensed structural formula, this time using parentheses, so that we can show our repeating CH2 groups. And again, we're doing continuous chain, so looking for that just straight long chain. So we always have CH3 on the end. Then we're going to have a bunch of CH2s, and then the other end is going to be a CH3. So if there's 10 carbons total, I've got 2 for the ends, which leaves me with 8, so that means there's 8 in the middle. So if we check hydrogens, we've got 6 from the 2 ends, plus 16 from the middle is equal to 22. Last one here is just the reverse. We want the molecular formula, so we need number of carbons and number of hydrogens. So we've got 1, 2, plus 4, so there's 6 carbons. We've got 3 plus 3 is 6, plus 8 in the middle is 14. And just as a double check, that is 2n plus 2, so we know that that is a good alkane. In all of the examples we've looked at so far, we've looked at continuous chain hydrocarbons. However, things don't have to be in a linear chain. We can have branched hydrocarbons. So this is where we have groups of carbons and hydrogens branching off from a main structure. So instead of having 5 carbons straight across, in this case I've got 3 and 2 coming off the middle. Another way I could draw those 5 is 4 with 1 coming somewhere off the middle. Or what if I have 3 and 2 coming off the same carbon, or going, both of them are off the same carbon instead of being in a chain like we saw in the first example, right? So each of these are fully correct ways of drawing that C5H12, okay? Whenever we do these as condensed structures, whenever you have that branch is going to be put in parentheses, okay? The way we know this is different than previously using parentheses is there's no number on the outside. So this isn't a repeat. What this is saying this branch is coming off of the previous carbon. All right. So if we look, we've got a CH3. So here's CH3, followed by a CH. So here's CH. Then we've got the branch coming off, CH2CH3 here in parentheses. And then lastly, we have a CH3 on the end. Okay. If we look at the next example, first we have a CH3, followed by a CH with a CH3 branched, so it's in parentheses, CH2, CH3. Okay. So hopefully you're seeing how you can go from the kind of full structure to a more condensed structure when we have branching. Then for skeletal, it's really the same. So take your full structure and just erase the hydrogens. So we've got 3 carbons with 2 branched off. We've got 4 carbons with 1 branched off. 3 with 2 branched off, both coming off of that middle carbon. So we're going to draw our condensed formulas as well as skeletal formulas for each of these structures. So we've got CH3, followed by a CH, and then this group is branched, so it's going to go in parentheses. And then back up to the main chain, we have another CH3. If we look at B, we're going to start with CH3, attached to a CH. This CH3 is going to be in parentheses because it's branched off. Back to the main chain, we've got CH2, ending with CH3. Last example, we have CH3, attached to a CH, attached to this group, so that whole group is going to go in parentheses. Back to the main chain, CH2, lastly, CH3. If we do our skeletal, we're going to, in this first example, have 3 carbons and then 2 branched off of it. Next one, 4 carbons with 1 branching off. Next one is another 4, and this time 2 branching off. So there's your skeletal structures.